Welcome to my workshop, guys. It's going to be on Microsoft Azure and developing with serverless cloud functions in Python. I tried to make this as beginner friendly as I possibly can, but there are maybe some terminology that you may not understand if you are really introduction. If you just kind of introducing yourself in CS, things like web requests, push requests, get requests, that like internet communication lingo. I won't be covering that, but we will be kind of using it. But most of that's extracted away, so don't worry about if you don't know that. Like it's not a big deal. So the workshop goals for tonight, I want to help you get set up with Microsoft Azure, learn a little bit more about cloud and serverless computing, writing some cloud functions that can read and write from a database, and deploy all of that on Azure. Hopefully with this knowledge, you can use this to quickly build an entire backend for your next hackathon. So hopefully you're going to Night Hacks, and this could really help you get started pretty early for this weekend. A little bit about me. I'm the senior CS major. Here at UCF, I'm a lead backend developer at Night Hacks. I love national parks, and I'm interested in making the world a better place with machine learning. If you have a LinkedIn, feel free to connect with me or DM me on Discord. So for the agenda for tonight, we're going to first go into what the cloud is in case you aren't already aware. Going to be setting up our cloud resources and development environment, as well as getting ourselves introductions to serverless cloud functions and cloud databases, how that all works. Then we'll actually go into our code, setting it up and testing it locally. You are free to follow along with me if you're able to get an Azure account set up. But I'll be live coding, so like if you are able to follow along, that's great. If you can't, just follow my screen. So what is cloud computing, in general, right? So cloud computing is really hosting and managing your data on something else that's not your computer. So if you have a website, you might want to host that on Azure. If you have a database, you might use Google Cloud Platform. If you have anything at all, like you can use AWS, like there's so many different resources that you can use. Cloud as an abstract sort of definition is just having something that runs code that isn't local to you. And that could be somewhere as far away as like Asia or like the West Coast of the US. So why do we really need the cloud, right? Because these giant tech companies run cloud ecosystems, it tends to be really flexible, right? You can deploy a database on Google Cloud and hook it up to a website on Microsoft Azure. You might introduce functionality into your project that you might not otherwise know how to do or might not have the resources to be able to do. Things like whole machine learning ecosystems, a whole like pre-trained machine learning model might be purely cloud-based, and you'll never see any of that code. All you have to do is essentially hit up a web endpoint. As for security, because these large tech companies run these cloud ecosystems, you tend to have some of the best security professionals making sure that your data is secure. And since that cloud, by the definition of cloud, it's all distributed. It's not like in one location. If your computer shuts off, it breaks, like your data is all gone. But if your data is hosted on 3 separate different continents, if a meteor strikes, North America, if your data is on Asia, it's fine. Like it's backed up, it's secure. And because a lot of companies nowadays use the cloud, there's a reason for that. It's because cloud is typically synonymous with, businesses being competitive. When you have the cloud, you have a lot of the cutting edge tech right at your fingertips. You don't have to build your own servers or like worry about things being out of date. Some company in Washington is probably going to take care of that for you. And as for the environment, it may seem a little bit counterintuitive, but a lot of cloud computing data centers are hyper efficient. If you think about a building that's running maybe, I don't know, a couple hundred computers on 24/7, you might think that might, waste a lot of energy. But it's kind of the opposite of that. Yeah, all computers are running, or like those computers are running pretty much 24/7, but all those resources are actually being used for something. It's not computers sitting idly. If you're on your laptop and you just leave it on overnight, your computer is not doing anything. But a server in California, for example, if one company stops computing for the day, that server is being reallocated for another company's uses. Those computers are running, but they're always being used to its maximum potential, and it's never energy that's essentially going to waste. So that's great for companies. Why should you as a student use the cloud? Cloud is a great way to introduce functionality into your hackathon projects. When it comes to maybe like having a database or something ML related, or maybe something for big data, I highly doubt any of us in this room could do that from scratch, or maybe even have the time to introduce that functionality into a hackathon project when you only have 36 hours of code, or sometimes even 24. Getting something set up as big as a whole database can take about just 10 minutes. And that's not even 10 minutes of you coding. It's 10 minutes of the cloud provider doing everything for you, and all you have to do is just click a few buttons. Learning cloud gives you a lot of real-world skills, and because all these big tech companies really use it, they tend to like it when they see it on your resume. So that's a lot of information about cloud. We're actually going to be going into Microsoft Azure right now. And before we do that, I need to make sure everyone here, if you want to follow along, has Python installed. I actually don't know how to see the chat, so I can't see if like people want me to like, I don't know. Here it is. Okay, cool. So if you don't have Python, go ahead and install this now. Go to python.org/downloads. I can post that in chat. There's a question that says, why would I want to use Azure versus AWS or something else? When it comes down to it, there's no real difference. But some cloud providers, like AWS or Azure, might offer incentives for you to get things up at a lower cost. I know that Firebase, Google Firebase has a really, really nice free tier. You can get essentially a full stack application up for free. Yes, they're basically the same. Some cloud companies have things that others don't, like Firebase is a little bit limited, but Azure has a lot more. The only difference is at the end of the day, you might be paying more somewhere else. When you are installing Python, make sure that you are adding the environment variables to your computer. I don't know how it works for Mac, but I know for PC or Windows rather, like you need to add it to path, and that's something that you have to take care of. So normally in other workshops, it doesn't matter what text editor you use or IDE or whatever, but tonight you really do need Visual Studio Code. The reason why, thanks Rob, the reason why is because of a function, an extension called Azure Functions. This allows you to deploy to Microsoft Azure with the click of a button. There's like no command line, nothing like that. It's just a one-click thing, and that's pretty much what Microsoft wants you to do. Deploying to the cloud without this extension, without Visual Studio Code, is a lot harder, and I would not be covering that. Yeah, so if you already use Visual Studio Code, just grab this extension and you're good. In order to get that, just click this like building block button on the top, on the bottom like left-hand side of your screen, and just search up Azure Functions. I can pause here in case anyone has questions. I'll give everyone about like 20 seconds to catch your breath. It's like information bombardment right now. My Discord, if you are in the Night Hacks chat, is I'm tagged into organizers, so I can just look up Justin and that's it. But if you aren't in the Discord, it would be that. There is a command line tool, but I don't know how to use it, so I'm not gonna be covering that. Yeah, definitely take your time if you're installing things. I'm gonna wait another like minute or so. This isn't highlighted by default. You do have to add Python to environment variables. That's not a default option, and you do have to do that for this workshop. You only need the Azure Functions extension. You don't need anything else. Just ignore anything that says Azure and just get Azure Functions. Okay, wait about 10 more seconds for everyone. So there's a question about, is my best recommendation for learning about Azure the Microsoft documentation, or is there any other resource that you think is really helpful? Probably the documentation. I don't know, I'm weird. I don't look up like YouTube videos typically. I try to look at documentation as much as I can. When it came to learning about Azure, I never actually used any like online guides. It was just looking up specifically how to do like thing A. And then once I got that done, like I look at documentation to do thing B. And it's like all that thing. But to me, it's just documentation. Okay, so I'm going to move on to the next slide. This one I'm going to have to trust that some people have set up an Azure student account already. Because I already have one, I cannot actually share my screen and do it along with you guys. But assuming you made an account, it should be really quick. I'll drop this link into chat right now. It should be really quick. I don't think you have to put in any payment information. It should be like 5 minutes of your time. But yeah, here's the PowerPoint, by the way. But I will show you what it looks like once you actually get it set up. The Azure account, I mean. So hopefully everyone can see my screen still. But once you set up an Azure account, you are probably gonna get a page that looks like, I don't know, sign up for free credits or click this if you're an educator. It has some buttons and like, I don't know, it looks really different from mine. And that's expected. It's because mine is not a new account. If you're a new account, you have some additional guides that help teach you the platform. But something that everyone should be able to see is the search bar up here. It says like search resources, services, and docs, right? Yeah, Alexander, you should be able to see my screen if you already have one, or maybe click something else, I don't know. But regardless of what you see on your homepage, is everyone able to see like this top search bar right here? Great. So in Azure, there's like a hierarchy you have to follow. Things like databases or web applications or Azure functions are things called services. Services belong inside of resource groups. Think of resource groups as like a way to organize your many different services. So before we get into making a database, we have to make a resource group. So we can just type in resource group wrong. Type in resource group up here, and you should get a button that, well, says resource group. It's like a little cube icon. Go ahead and click that, and you want to click add. And this makes a new resource group. My webpage is taking a while to load. That's awkward. Yeah, it's really funny because like a week ago, maybe not a week, but a couple of days ago, there's an Azure outage. So like all of Azure was offline, and that was like really bad. So assuming that your page loaded successfully, mine just did after like, I don't know, 20 seconds, you should get this page that says create a resource group. Go ahead and call it whatever you want. It does have to be a unique name, I'm pretty sure. Actually, no, I lied. It doesn't have to be a unique name. So you can call it whatever. I'm pretty sure you'll get allowed to. I'm gonna call it, I don't know, Night Hacks Live Demo. You should get a little checkbox right here on the right-hand side if it's successful. If you do that, just click Review and Create. There's no other setting you have to care for, and click Create. Once you do that, you should be able to go to your resource group, and it should be an empty page that looks like this. Did I lose anyone yet? Just making sure. Did you? You shouldn't have to sign up for a free trial. And if you're not eligible, that sometimes happens. Did you ever sign up for like a student account in the past? I think that's why. Did you register with your Knights account? Okay.
Would it be easier if I just talked?
Yes.
Okay, so
Like
yeah, I
going through
did make an
the
account
whole
a couple
yeah.
months ago.
Okay. And are you not able to make a resource group or?
No, it says that this is an education benefit, sign up for education benefits, and when I did, it said you are not eligible to renew Azure for students.
Okay. In that case, that I know of that problem, and I don't think there's any way to go around it. You are able to use Azure for Students, I think, once. You can like apply for renewal for credits, but that's like a whole application process. And I don't think that there's any way for me to like help you with that. But you can still follow along with the workshop, and like once that is sorted out, perhaps with like a Microsoft sponsor in the chat for Night Hacks, I can help answer some questions privately if you want to explore this further.
Okay, thank you.
But yeah, if you're able to claim, yeah, Kimberly, if you're able to claim your Azure credit now, please do that. The reason why I can't like have a single generic answer for all of your problems is because Microsoft does things really weird. And if you like even click one button differently, it's like totally different. Liana, I'm not sure if you have to sign up for a free trial. You should have these resources automatically. If you do have to sign up for a free trial, I think you have to put in your credit card information, and I'd rather you not do that. Yeah, you might need credit card stuff. And if you don't want to do that, that's okay. If you want to just like put in your credit card information, I mean, it's totally not required. We're not gonna charge you. We're gonna stick to the free tier for everything. But I understand like if someone's like uncomfortable about putting the credit card information for something they will probably won't like be using or something. So I understand. Okay. I'll be moving on past the resource group page, but I'll be sticking here in case someone's lost for the resource groups. Again, you just click add, create a new resource group, call it anything you want, and just click review and create. There is no additional steps for that. The region, again, here, it doesn't really matter. You can be whatever you want, but put East US for the quick speeds. Okay, so is everyone able to move on? There's a lot of information, like Azure is a little bit weird for UI, so I understand if like it's easy to get lost, but I'm gonna take as much time for questions as you need to. Okay, so assuming you have a resource group set up, make sure that's open. It should be the title of the resource group on the top left-hand side right here. And you want to click add. So we're going to add two things. We're going to add an Azure Functions app. So if you just type in functions, it should pop up. Again, it's called Functions app. I'll be going into exactly what this all is in the next slide. The reason why I'm not saving the setup stage for last is because setting up the database does take almost 10 minutes to initialize. So I'd rather get this out of the way now and explain what we're doing after we're all set up. Want to click create for your function now and call it literally anything. For me, I'm going to call it Nighthacks Live Demo Functions. If you get a little checkbox right here, it means you're good to go. We're going to be using code, not a Docker container. And for our runtime stack, we'll be using Python. The version number doesn't really matter. Let's just use version 3.8. And region, East US for the quickest speeds, of course. After this is done, you can click review and create and click create. It does take a couple minutes for it to set up, so you can go ahead and just go back to home and go back to your resource group. And now we're going to create our database. Going back to the resource group, if you see nothing here, that's fine. It's because it takes a little bit of time to populate. You can click add, type in Azure CosmosDB, and just like the Azure functions we just made, you want to click create. So you can name it whatever you want. You can call it, for me, I'm going to call it Night Hacks Live Demo Database. Your API is going to be core SQL. And I'm pretty sure the rest of the settings just keep it as default. It would be provision throughput, free tier discount. For me, it's disabled, but for you, you should be able to have a free tier discount. And from there, just click create. I understand I'm going a little bit fast, but I will be pausing after this in case someone gets lost. Oh, for the database, Robert. Oh, the option you change. Here's my page. The API is core. I'll type it out. Location, just East US, and free tier on. That's all you have to worry about. The rest you can keep it as is. Cool. Yeah, Nicholas, I'll pause right after this, and then I'll help you out if you have any questions. There's a lot of settings that I won't be talking about, like geo redundancy. It's not going to be part of this workshop. That would make it far beyond beginner friendly. Okay. Now I'm going to take about a 2-minute break here so that we can all catch our breath and start out any issues that may have come up. To recap, we made a resource group by typing in the search bar, resource group, clicking add, typing in the name, and then clicking create on the bottom left-hand side. From there, we go into the resource group we created. We click add on the top left-hand side, and then we added 1, a functions app, and 2, CosmosDB. Yes, Adam, you have to, or you should apply a free tier discount with setting up CosmosDB. Timothy, if you're unable to access CosmosDB, that's okay. Don't worry about that. You're still able to follow along, but your cloud functions aren't going to be able to talk to a database, but you can still get it deployed. Yes, I'll stay here for about another 2 minutes and answer any questions that may come up. Okay, a couple more moments. When you say account type, let me open up CosmosDB. Oh, keep that default. I believe it's default is non-production. Cool. Yes, the API is core SQL. I know it says SQL. We're not writing SQL queries, if you know what that is. Liana, if you're unable to get the CosmosDB app, is it because it's not included in Azure Students or something? Shoot. Don't worry about the database if you do not want to input your credit card information. I think the only way to go around that is to have some kind of paid subscription. Azure is a little bit weird sometimes. But if you can't do that, that's okay. You can still follow along with the functions part. But when it comes to inputting data into a database, you just have to follow along with me. Okay, is anyone still setting their stuff up? Cool. I'll wait just a moment for you. I'll continue in a moment. There isn't any code that actually comes for quite a little bit of time. So you're still setting things up. That's okay. Just listen along. Okay, so as we wrap up setting everything up in Azure, I can finally go ahead and talk about what exactly we're building and what are these resources that we created. So for those new to programming, you might hear the words backend and frontend thrown around a lot. In summary, backend is code that you can't see, while the frontend is code you can see. The backend handles logic and data manipulation, and the frontend makes things look pretty and functional. That's obviously there's a little bit more than that, obviously, but like that's basically the main distinction. So we made an Azure CosmosDB service, but what really is that? Azure CosmosDB is a cloud-hosted, obviously, NoSQL database. NoSQL really is a catch-all term for anything that's non-SQL. SQL stands for Structured Query Language, and it's basically the database format that allows you to type things like select star from database, that sort of thing you see in like business classes essentially. It's really, really common, and you as a programmer still need to know it, but this is like super, super critical. We're not using SQL, we're using something else that's more associated with programming, NoSQL. CosmosDB comes in a few different flavors, right? There's the core API, the one that we're using, that's kind of like SQL. You use SQL languages to query a NoSQL database. It also comes in Cassandra and Gremlin. Cassandra is kind of like a column type of database, where if you imagine databases being stored in like an Excel spreadsheet sort of style. And Gremlin, which is a graph type of database, where each object in the database is like a vertex on a graph, and there's edges connecting each object. It's pretty cool. But in order to keep things simple, we're going to start with core. This has the most support, and it's what CosmosDB came with originally. Everything else was added on long after. This workshop should only last until maybe, I don't know, about an hour total. Shouldn't be long. So like maybe 8:30, 8:45. When it comes to Azure CosmosDB, there's a couple of key terms that you really have to worry about. This doesn't really come into play too much. It's more for just trivia. So data in CosmosDB is organized in a database. You typically only have one database. Inside of a database, you have containers. A container is something that holds a specific type of object. For example, if you have like, I don't know, a music application, your container might be something that holds songs or holds playlists, and you'd have multiple containers for each different type of object. Inside of a container, your information is separated by partition keys. So in order to visualize this, imagine we had a family container that holds objects related to family information. A partition key might be last name, where logically, inside of the family container, you group together families by their last names. Again, this is not something that's going to be too relevant to the workshop, but it's good to know what exactly we'll be typing out, because these terms come up inside of the code. So on to the cloud functions part. What really are these serverless cloud functions? Functions refer to a snippet of code. To put it very simply, a function can literally be something that just adds two numbers. So like int add two numbers, A and B, you return A and B. That would be a function. If you're like have any programming experience, this would be like, this is just that. There's nothing more, like it's not complicated than that, or more complicated than that. For cloud functions, this refers to functions that exist on cloud servers. So if you imagine, the function add two numbers, you take that function and the code that goes along with it, and you put it on a cloud server. And the server runs the function, just that function, nothing else, just a function. The serverless part refers to cloud functions where the cloud servers are fully managed by our cloud provider. I know it says serverless, but it doesn't mean the server doesn't exist. Serverless refers to how you don't run the server, the company hosting it does. This distinction is a little bit important because it's possible to have cloud computing, but not serverless cloud computing. We're working with serverless cloud functions in this workshop because Microsoft is going to be handling all of the deployment from start to finish. If you were working at a business, you might not be using serverless computing. You might want to have all of that configuration options available to you, and you can fine tune whatever you want. But for serverless, all of that is abstracted away, and you only touch the code, nothing else. Some common cloud functions out there might be, AWS Lambda, Azure Functions, obviously, and Google Cloud Functions. AWS Lambda is, I think, one of the most common things to hear within cloud computing. I think AWS Lambda was like the first cloud function to be out there. So very simply, cloud functions have three main parts. An event listener, which can be anything like a web request. You send the web request to a cloud function through the internet. Some timers. You might have a cloud function automatically execute some code like once every 24 hours. Or your cloud function might listen to a database. So if something in the database gets deleted, your cloud function can listen for those changes and react to it. And then obviously, like with all functions, you have some kind of code logic. You might do some math, you might update a database, or you might call another API to do that does something else. And universally, cloud functions all respond through the web. So you might send a status 200 for something successful. It's just any sort of generic response. So why do these serverless cloud functions exist? It seems kind of unnecessary to have a whole cloud ecosystem dedicated to just running a snippet of code. So cloud functions are really important because it does four things really well. So when it comes to eliminating code duplication, what this really means is if you have this e-commerce website that has a website checkout system and a mobile app checkout system, it wouldn't make sense to code the same thing twice on two different platforms. What you can do is code a checkout cloud function that's stored in the cloud and have your website and your mobile application access the same cloud function. So you don't have to code the same thing twice. You code things once, but two different platforms can access the same code, even though they exist on totally different services, totally different platforms. With cloud functions, it's also really easy to make code that runs on a schedule. So for example, if you wanted to back up your database contents once a week, you could use PowerShell and I don't know, Windows Task Manager to schedule something on your computer to run locally. Or you can use, most cloud functions come with this thing called automated timers, where you can just go through a UI and click run this function once every day, and it would do that. There's no management needed. It's really, really simple. Cloud functions are really good when it comes to meeting high demand when you need it to. What I mean by this is pretend we had a function that sends some emails, right? There's tons of emails, 1,000 to be sent. If you had, I don't know, normal code, right, on a regular backend server, that function that you write on a regular platform, maybe it runs on your desktop, that's not a cloud function, it might take 20 minutes for that function to execute, to send 1,000 emails, because it's one computer. When it comes to cloud functions, since each function exists on its own separate computer, you can have 1,000 different computers all running the same function that all do one task. Each computer essentially sends one email. Something that might take 20 minutes might just take a couple of seconds because you have so many of these concurrent processes happening at the same time. It's the difference between sequential and things that happen concurrently. And something that's possible with Cloud Functions that isn't easily possible with something, with anything else really, is code that executes in response to something. So imagine we had some Cloud Function that listens to a chain in a database, for example. If a new user signs up to our service and has a new object being created in the database, your Cloud Function can listen to that. You might get notified right away if a user signs up. And that's as simple as just hooking up a Cloud Function to the right API, and that's like, it's totally taken care of. So yes, technically you can do that with regular code, but functions make it a lot easier. It's not a matter of like, it's possible with this, but not possible with that. It's more of how, like, it's more of just eliminating as much complexity as you possibly can. There's no cross-compatibility issues, so that your entire backend can be built with 20 different programming languages, and they would all work together because you're all in this like little ecosystem. You don't have to worry about cross-compatibility. And since each function is billed separately, if you have one function that's commonly used, but the rest are maybe called like, I don't know, once a month, you're not gonna get charged for that. Versus a regular server instance, you would be charged equally for all server or for all functions, even if you're not using it. So just like before, that's a lot of business logic, but why should you as a student use serverless cloud functions? They are a really, really easy way and super simple way, relatively speaking, to tie together projects for hackathons. When it comes to time, it's easy to build an entire backend system in, let's say, an hour, just using cloud functions. You don't have to worry about deployment. You don't have to worry about managing like a bunch of different packages to make a giant, I don't know, web application backend work properly. You can just code up a function, hit a button, and everything just works. So we're going to be getting into code in just a short minute here. But in summary, we are going to be making two different things. Some cloud functions that can create, read, update, and delete database, or delete data from our database, and a Python script that can send the web request to our cloud functions to see if they work. And that's where the web request stuff comes from. Nothing else involves web requests other than the local Python script. So I'm going to be sharing my GitHub, where you can download my code in case you are unable to follow along. I put in the chat. Okay, so if you do want to follow along, open up Visual Studio Code now. Let's just make new folder anywhere, and you can click this Azure button on the left-hand side right here. If you downloaded the Azure Functions extension, you're able to click this button right here that says Create New Project. And this works even if you don't have an Azure account. Like this Create New Project thing, that works no matter what. Oh, Turner, if your database location is West US, it doesn't matter. Like it's not like anything's gonna break. You just might like have a little bit of latency that wouldn't happen if you're on East US. There's nothing that would break, so don't worry. So we can create a new project. Yeah, Kimberly, we're choosing Python. Create a new project right here and click Python. Select our Python interpreter. So if you installed Python and added to the path, this should be populated with something Python related. And from there, we're going to click HTTP trigger. This is shorthand for web requests, essentially. And we can call our function, I don't know, create data. Doesn't matter what you call it, but this function is going to help us upload data into our database. Kimberly, are you referring to the Visual Studio Code, or are you referring to Azure's portal, like online on the website? Okay, great. Are you referring to here where it says create a new app, Python right here? I don't know if you can see my screen or not. You do not have that option? Or are you referring to the Python interpreter? Okay. When you installed Python, were you able to add that to the environment variable? Okay, for that, I can help you separately after this workshop, because that does like require a little bit more configuration that I would have to like look into your computer for help you for. But if someone in the chat can help, that would be great. Make sure to get the Azure extension right here, Azure Functions. Make sure this is installed. And yes, I'm in the root directory. It doesn't matter which directory I'm like, the extension will understand where to be, but stick to the root directory. You just select anonymous for authorization level. And once that is done, assuming you're able to follow along, you should get this page right here in a file called initpy. This is auto-generated by Azure. The template should be HTTP request. Yeah, of course. Here, let me close this out. Yeah, HTTPS trigger. Yeah, in order to start over, click this little triangle button on the left-hand side, should be Azure. And under Azure Functions, you can select Create New Project right here on the top left-hand side of my screen. From here, you can click the folder you're currently in or browse for a location. Click your language, which is Python, HTTP trigger, and call it anything. The authorization level should be anonymous. And yeah, something you might have to do is restart Visual Studio Code. That does, I think that does fix a lot of problems in case you can't see this extension right here. Cool, were you able to set it up? Great. Okay. Yeah, until you restart, that's good. Glad it works now. But once that is done, you should get some auto-generated Python code that looks like this. So how this works, let me clean this up a little bit so it's easy to understand. I'm going to delete this. Going to delete this and delete this. So here's the format of the Azure Functions template, right? So here is our main function whose input is, for our example, it's going to be a JSON object. All of our code will go here. This is where our logic is. And for sending a response, all of it's here. So for example, if you are calling this function, you would have to input a JSON object that you extract using this line of code. And then in order to get a response, you'd have to use this line of code. The exact methods that like operate under the hood, or like why is it called func, why is it called HTTP response, like all of that is abstracted away. That's just how Azure does things. So don't worry about too much about the naming scheme. This is, again, like kind of like a beginner sort of centric workshop. So kind of ignore the terminology for a little bit. But yeah, this is all there is. Signal, input, and code. Okay, so once that is done, in order to deploy this, just to see if it all works, you have to go back to the triangle icon right here on the left-hand side. Click Deploy to Function App. It's this blue arrow that's pointing towards the roof. Click your subscription. It's going to be called Azure for Students or Azure for Student Starter, one of them. And select the Azure Functions app we made earlier. If you do not see this option, go ahead and make sure you sign into Azure by clicking Command Palette or Control-Shift-P and typing in Azure sign in right here. From there, you have a web page open up where you can sign into Azure. Again, to repeat, in order to deploy this function onto the web, just to test this out, you can click this blue arrow right here, deploy the Functions app, click your subscription, click the Azure Functions application you made earlier during our setup stage. And you should get a pop-up that's saying like, do you want to deploy? You just click yes. From there, it should take about a minute to deploy. You can track the progress on the bottom right-hand side of your screen. And once that's done, you're able to go onto Azure and see your function stored on the cloud, essentially. We'll be exploring that once this is done and deploying. Nicholas, when you go and sign in, you click Command Palette, Azure sign in, and what pops up exactly? You should get a page that looks like this, right? Interesting. It might be really slow. It's weird that you don't get anything at all. You should get something. Yeah, Nicholas, you might have to wait for that page to load, or check to see if there are any like hidden error messages that's not popping up. To deploy, again, click this blue arrow right here, top left-hand side of your screen. Click your subscription, and click your Functions app that you made. Cool. Okay, so for me, it finished deploying. Oh, after you sign in, everything's handled. If you click sign in and it says you're successfully signed in, just close the page, don't worry about it. Your Visual Studio Code is synced up with Azure like automatically after that. There's nothing you have to handle. So if you see the successful sign-in page, then good, close the page and try deploying. If that works, you are able to see your Python code by going here into your Azure Functions app that you made earlier. And you can see here, for me, I called my function create data. It is an HTTP trigger, and it's on the cloud. You can click it, see your code, and see exactly what you deployed right here. It may take a few minutes for a code to appear. It is not automatic. So if you don't see it right now, but you made sure to click the blue arrow and deployed it to the right application, then you should be okay. Just give it a couple minutes. Okay, so that is how you make a new Azure function and deploy it. In the sake of time, I will be transitioning to my pre-made code. I won't be coding up everything from scratch. But, oh, the code is right here, sorry. Right there, Gabriella. Oh, sorry. You can go into Azure, go into your resource group, go into your functions app. And if you see the left-hand side right here on this like navigation panel, if you see the word functions, you want to click on that and you can see your code right here. If you don't see it, give it another minute, it's probably still deploying. Great, perfect. In order to see your code itself, like line by line, you click on your function, click code, and it should pop up right here. When it comes to linking the account, go here, click Control-Shift-P or Command Palette under the view navigational panel. Click Azure Sign In and sign in with your credentials. If you sign into the right account, which is probably your Knight's email account, you're able to see this page called You are now signed in, close this page. If you see this, go ahead and close. And from there, if you click refresh, you should have the right credentials be populated and you're able to see all your functions. Make sure you're refreshed. If you can't see, just go ahead and refresh this button right here. Yes, all of this is going to be uploaded later tonight. Don't worry, including the code. Okay. From there, I'm going to quickly go over how to connect to the Cosmos database we made. If you are able to make a database, this is something really important. If you're unable to, that's okay, just follow along. So let's look at this code right here. There's two really important variables that you have to worry about: your endpoint and your key. Your endpoint is the website, quote unquote, where you can access your database. Your key allows code to communicate to that database. Never share your key with anyone, essentially. Don't put it online, don't put it in GitHub. Make sure if you're uploading something to the website or to any sort of website, this key is always hidden away. It's important because if someone grabs your key, they can mess with your database as if they were like an administrator, and that's not good. So for me, because this is a live coding example, yeah, this is all APIs. Like if it deals with the cloud, it's probably going to be an API. Because it's a live coding example, you are going to see my private key, and I don't care about that. But for anyone else, don't share this. In order to get your key and your endpoint, go ahead and go into your database that you created earlier. By now, it should be done. And you should be taken to this landing page right here. In order to get your key and your endpoint, you want to go here to the left-hand side where it says settings and then keys. If you click that, the endpoint is this URI. You can copy that here and paste it. For your key, you can either be your primary or secondary key. Just go with primary. Is everyone able to see that? Cool. So on line 10 right here, you initialize what's called a Cosmos client. This client allows you to get access to all the APIs that involve messing with your database. So write out this code right here. Cosmos client equals a new Cosmos client. You're initializing a new Cosmos client object if you're familiar with object-oriented programming. This Cosmos client takes in two variables, endpoint and key. So if you remember from earlier, CosmosDB is set up so that there's, I believe, two levels. Level 1, the database, where all your information belongs. Setting up your database can be done in these simple lines of code. You declare your database name. I called it demo database. And you initialize it by using this line of code, Cosmos client dot create database if not exists. What this does is if the database of this name doesn't yet exist, this line of code creates it for you. If it does exist, then it doesn't do anything. The same thing goes for our container here. Remember, information inside of a database goes inside of containers. We can initialize a new container here called demo container, for me at least. You can do Cosmos database dot create container if not exists. This creates a new container of a specific name, partition key, and offer throughput. Do not worry about this last variable, throughput. That's not important to this workshop, but the partition key is a little bit important. If you remember before, in the example I went over, inside of like a family container, the partition key is used to distribute data within a specific container. So in the family example, our partition key was last name. You want to split families up by common last name. That is the partition part of the partition key. For me, since my data is pretty generic, I don't have anything special that I want to like partition things by, so I just use /ID. This would be like what you would use to in a hackathon unless you have something like really important that you want to partition by. Since you can't leave it blank, I just put ID personally. This essentially does nothing, yeah. The endpoint can be found here. If you go into your database, left-hand side, click keys. And the endpoint here is called URI. URI would be synonymous for endpoint. The partition key is both. It's for performance reasons, but you're able to query by a specific partition key if you wanted to. So your answer to that is performance or organization. It'll be both. The reason why I'm not getting into like exactly how this deals with, database performance is because that would be too much definition to cover in this workshop. Cool. Is anyone lost or stuck in a prior step, or is everyone okay? I'm gonna take another minute to make sure everyone can catch up. Depending on internet speed, it might take a little bit of time. I've never seen it take 10 minutes to deploy, but I wouldn't be worried about it as long as you have no errors. The errors is what's scary, but just taking a long time, it shouldn't work, or it shouldn't matter. I mean, but assuming everyone's able to catch up, we can go into exactly how our create, read, update, and delete code looks like. So everything here is basically one line. It's not too much to read. In order to create data inside of the Cosmos database, you just do Cosmos container dot create item, where the input is some kind of object. In Python, an object would be like a dictionary. A dictionary would have key value pairs. If you're familiar with JSON, it would be the same thing as that. I will show you exactly what that looks like in a moment. If you're able to follow along and do have Python installed, you can actually test all of this out yourself by using this test demo script I made. In the test script, you have 4 variables here: the create data URL, read data URL, update data URL, and delete data URL. This relates to the Cloud Function URLs you made earlier. Now, why does a Cloud Function have a URL? Because you're hosting on the cloud, you have to communicate with somehow. And in order to communicate with anything in the cloud, you typically have a URL associated with that. In order to get these fields, you can go into your functions application. Go into your functions. Click on your function and click Get Function URL on the top here. Robert, are there any APIs, or rather, are there APIs for whatever backend language you want? Yes, I picked Python because it's easier to look at a glance without any programming experience, but JavaScript APIs exist, C#, Java, pretty much anything. In order to get these URLs, again, you just click on the function, click Get Function URL, and copy and paste. Once that is done and these 4 URLs are populated, then we can go ahead and run this script. I'm going to try to make a database object that has this property. The ID is going to be called 123. The name is going to be called fruit smoothie. And the special thing about a database like this is the data types can be anything from a whole array or an entire nested object. So in this case, ingredients of our smoothie is going to be an array. The properties of the smoothie is going to be an object. If I run this script, we should be able to see this object being created in our database. So I can do Python test demo.py. And cool, looks like we successfully sent data to our cloud function called create data. And if we look in the database, you can check this out manually by clicking Data Explorer on the left-hand side, clicking our database container, and looking inside items. As you can see here, we have a new database entry that has the exact same object as we made right here. ID matches to 123. Our name is Fruit Smoothie. Our ingredients and properties are correctly filled. And you have some additional metadata here. You can ignore that. That's auto-generated and not really relevant to anything except for really, really niche like performance reasons. So in summary, what we did was we made a cloud function that initializes the Cosmos client, makes a database, makes a container, and creates an item in the container. In order to actually execute that cloud function, we grab the URL and we sent a web request that had this object. In order to actually read the object, all we need is the ID and a partition key. Since my partition key was ID, as you can see here, our item ID and our partition key is the same thing. Hypothetically, if your partition key was something like name or something like, I don't know, type of smoothie, for example, then these would be two different values. You just have to make sure they line up. If you want to update an item, all you have to do is do Cosmos container.read item as if we were reading the data, and then do Cosmos container.upsert item with a new item. Now, what does this look like, right? So if we go back into our test script, we can run it a second time. And see here, originally, our object name was Fruit Smoothie. Now, if we refresh this database, it has changed to Berry Fruit Smoothie. Everything else is still the same, but the name has changed. Okay, Robert, you asked a question about serverless. Are you able to write to a file or set variables that persist, or does all your state have to go into the database? Data has to go into the database, but that's not because it is serverless. Serverless only means that the code that you write is going to be managed by someone else. So it would be a Microsoft employee or a Google employee or an Amazon employee that is managing your server. Serverless doesn't refer to the absence of the server, just someone else managing it for you. But in general, yes, you would still need to write to a database even if it wasn't serverless. Yes, all you do is update your server code. You as a programmer, you do what you do best. You just code something and leave all the DevOps work to somebody else. And yes, you can also host a website on Azure, but that would be a whole separate workshop. So one last thing before we sign off here, we're going to test object deletion. In order to delete the object, you just do Cosmos container dot delete item and pass in your ID and partition key. Just like you're reading the item. You just switch the function call around. So instead of read item, it's delete item. Pretty simple. If you do that, then if we run our test script again, we can see that we have successfully deleted object of ID 123. And when we tried to read it again, it says resource not found. You can verify everything worked properly by refreshing this page. And seeing this database is empty. The ID 123 no longer exists. So code for this can all be found on GitHub. All you have to do is follow the README I put, change up the endpoint and your key inside of cosmosconnection.py, and inside of testdemo.py, put in your 4 URLs here. And that's all you need to do. In order to run this code locally, all you have to do is just call this Python script. In order to do that, if you have Python installed, is just do Python, type the file name, so testphone.py, and you click run. I made it really simple to read these outputs from command line so that you can see successfully if you create a successful read, update, and delete. And I believe that is all. Is there any sort of questions that anyone has left? Maybe they got lost, or maybe they have some additional questions regarding what you can do with this sort of cloud function stuff? If not, then I will be sticking around a little bit after the meeting in case anyone wants to ask me questions privately, or if they have any more generic questions that don't pertain to the workshop. I hope that the code really does help you in the hackathon if you're attending. Usually the thing that takes the longest is setting up the backend, but getting a connection to a cloud database can be done in quite literally 20 lines of code essentially. When it comes to other API keys, is it safe to write them in this Python file like you would on a server? So when you deploy this Python file, since no one else can see your deployed code, it is okay to write your keys and deploy it. The only place you don't want to put your keys is on a place like GitHub where just anyone can look at your stuff. I do not believe it is possible to censor a line when you commit to GitHub. So what I did personally was I made my endpoint and key right here. I deployed, and then when it comes to committing it on GitHub, I removed it. So if you look into Git right now, this should not exist there. There is an environment variable feature in Azure, but that's just another API you have to call. I can try to help you with that like during the hackathon itself. I don't know if I'll be mentoring or not, but if you ping me with a question like that during the actual hackathon itself, I'm sure that I can help you out. But that's like a whole other Azure service. Yeah, exactly. That is something you can do. Just putting your keys in an environment variable and Git ignoring it.
Guys, remember to do the feedback form. We always make these workshops better by hearing your guys' feedback. So make sure you fill that out so we can have better workshops. It is on the chat right now. And if you're watching this over YouTube, the link is nighthacks.org/feedback. And that will be in the YouTube description as well. Thank you guys.